Ladies and gentlemen, tinkerers and makers, hackers of all ages, welcome back to Drew's Lab. My name is Drew, and it is new printer day. And I am so excited because I was just about to head out to the gym. That's why I'm kind of dressed a little bit more casually here. And I heard a knock at my door, and there was a box sitting on my doorstep, and I'm looking over at it because it's off frame and you can't see it. And of course, I'm not going to get up and go pick it up because that would break the flow of this scene, right? We're gonna do that. This box, it's a thick boy, but as you can see, I've got an Ender 3 now. And you may be thinking to yourself, well, Andrew, what's the deal? Why do you need another 3D printer when you have a perfectly good looking CR10 clone right next to you? Well, that's the thing. So, as you can see, this is kind of a mess, and I'm going to give you guys a quick rundown of this printer in particular. So this is a Tevo Tornado, which is for all intents and purposes a Creality CR10 clone. That's why it looks exactly the same like it. But I've had a really rough experience with this particular printer. It worked well for a couple weeks to a month. I probably got it a couple months back around March or April. And it was doing all right, and granted I was new to the hobby of 3D printing, so I made a couple mistakes. But even with just like minor mistakes, I don't think that the cascade of failures that came with this printer are really all user-generated. So to give you guys some perspective, the bed on this guy is made of a really soft glass, and after a while, as you're trying to get stuff off of the bed. Now granted, I was scraping at it and I probably took some chunks out, but it would be the case that in some cases the glass would literally pull off of the bed and there would be a chip mark there. And so, no big deal. I got a replacement bed from Creality, which is the on-brand version of this printer. This is a clone of the Creality 3D CR10 printer. So I got the Creality 3D bed thinking, okay, I'll just put the bed and I'll set the offset and that'll work out. It worked for a little bit, and then the heat end had a lot of problems, so I replaced the hot end like probably 3 or 4 times. Had to redo the power supply because the power supply was going out, so that's a new power supply. I upgraded the board from an MKS, or the basic board that came with the Tevo Tornado, to an MKS Gen 1.6 board. That still didn't cause some of the issues. The printing was inconsistent. Long story short, this is not a good printer. I can't in good faith recommend that anybody buy this particular printer, and I kind of kick myself because the difference in price between this Tevo Tornado and an actual genuine Creality CR10 was probably 30 or 40 bucks. And had I known at the time that that $30 or $40 was gonna make this big of a difference, then I would have easily spent it. But I ended up trying to fix it, going back and forth, and through much frustration and probably $250 worth of extra parts, it's still on the fritz. So I made the executive decision, to basically break this one down, scrap it for parts if I can, see if the stepper motors are good, maybe I'll use it in another 3D printer design, and replace it with a genuine Creality Ender 3. Now, the CR10 obviously has a very big build plate. It is roughly a foot squared by 400 millimeters tall or something like that. It's pretty big. The Ender 3 is still fairly large. It's got an 8-inch square build plate, so not a huge step down. But another thing that I was noticing is when I was printing with this guy, most of the parts that I'm printing are not a foot in diameter or a foot in length or height, so it didn't make sense to have something this big, especially when the Ender 3 is half the price of this printer. So long story short, learn from my experience, always buy on brand if you can. Go for the big brands, Creality, Prusa, MakerBot. Don't go for the clones because usually sometimes they cut corners, and on a precision instrument like a 3D printer, you don't want to be cutting corners because you're going to pay more in repairing those parts and getting it back to spec than you do spending the extra money to get a genuine printer. But all that out of the way, all the sad talk out of the way, I will say that this printer did give me some good service. I printed a couple good parts on it, so it wasn't all for naught, and I learned a lot. So, and I in turn get to share that information with you guys. But it's about time that we replace it and we do an unboxing, and I can show you guys a couple tips for your first time assembling a 3D printer. Again, stuff that I learned along the way troubleshooting this guy. And I think it'll be to great benefit for you. No matter what printer you have, an Ender 3, a CR10, these tips should help you out when you're first assembling your printer and getting you off on a good foot. So without further ado, let's break into this guy. Okay, so let's kick things off by talking a little bit about why I chose the Ender 3. And in order to answer that question, we have to do a little bit of a history lesson and talking about how 3D printers and 3D printer designs and 3D printer companies build their machines. So if you've ever followed the history of 3D printing, basically 3D printing started as a proof of concept for something called the rep-rap movement. And rep-rap is basically an ideology that says that if you make a machine, the idea of a rep-rap machine is that the machine itself can create parts to self-replicate itself. So the old joke is you use a 3D printer to print more 3D printers. That's kind of rep-rap in a nutshell. And so RepRap is it's a community-driven open source kind of project. So back in the early 2010s, I believe, there was a lot of interest in designing machines that, like I said, can kind of self-replicate. And since it started as an open source movement, all of the plans for most of the 3D printers out there were available for free on the internet. And with that, you had guys like Joseph Prusa, who started Prusa Research, and he designed the Mark 1, 2, 3, all of the really famous printers that we know from Prusa today. And with that, the Prusa Mark 3 is widely regarded as one of the greatest 3D printers in pretty much all of existence. And because of that, you'll notice that there are a lot of similar designs. The CR10, the Ender 3, and all of their various clones kind of harken back to the design of the Prusa Mark III. It has this mono post in the middle, an x-axis that moves side to side, and then all that sort of stuff. So it's Cartesian. It's got X, Y, and Z. So companies Prusa starts by making their 3D printer. And since most of the plans are open source, or you can kind of reverse engineer, or you can take concepts from that design, then other companies begin to start innovating on top of that. So companies like Creality will create the CR10 and the Ender 3, which have a similar design to the Prusa Mark III, but they are still somewhat similar in their design and their electronics and their firmware and things like that. So, with that in mind, the Ender 3 is widely regarded as one of the best sub-$500 printers. And to that end, I'd done a lot of research because I didn't want to get burned again. I just told you guys about my story with the TiVo tornado and how horrific that was. And widely acclaimed, this is one of the best printers out there. So I decided to take a shot at it. I like the all-in-one design. That was a big thing that I was trying to get with my CR10, but the new revision of the Ender 3 has everything kind of self-contained, which I love because that means less wires and all that sort of stuff. And so, yeah, that's why I decided on the Ender 3. It's got a great build volume, especially if you're starting out, and for 220 bucks, it's not too bad. So I've opened this box. I've dwindled on long enough. First things first, definitely have a clean workspace. I'm not gonna tell you for a second that my workspace is clean. I've got a whole bunch of stuff going on here, but if you don't have a clean workspace, you can use the foam material. You can lay it down, and I'll show you here in a second, but you can lay it down as kind of a soft bed to work on. You don't wanna have like micro abrasions, like you don't want dust or particles on the part when you're setting pieces down and building stuff up, because it can cause abrasion, it can cause dust to collect on your parts, and it just doesn't look good, or it doesn't bode well, I guess you could say. So I'm gonna put this down and get this over here, and we'll take a look at this guy and see what's going on. Okay, so as you probably just saw from my visual confusion, this piece of foam actually has this backing on it, so I can't lay it flat and have a workspace to work with. So my bad, but I do have an ESD bag, and what an ESD bag is an electrostatic discharge safe bag. If you've ever ordered computer parts, they probably came in something like this, but the material on this is anti-static, so it keeps electrostatic discharge from nuking your parts, basically, and so this will work just fine as a small workspace that I can put parts on and not have to worry about dust and all this other stuff underneath. And okay, first things first, so RTFM, read the flippin' manual. With any kind of electronics or any kind of precision instruments or any kind of tools, You don't have to read it word for word, but definitely go through and read the manual. At least get yourself familiar with it. And qualified certificate. Oh, certificate of quality. I thought this was like a sticker or something. That would have been cool. But, and then there's a warranty card in here too. So I'm gonna read through this really quickly, get familiar. This is very, very nice. So it actually includes, if I'm not mistaken, a filament holder. That was something that the TiVo Tornado did not have, but of course you can always print them after the fact. So I'm very, very happy that there's a filament holder because that is a big deal. And if you don't have one, it gets kind of hairy. So good on you, Creality, way to include that. Okay, so some pretty basic stuff when it comes to 3D printers. It's actually kind of nice. A lot of manufacturers now are doing everything kind of pre-assembled, so you just have to put a couple screws in and do some things, and then that's that. So yeah, everything here looks good. There are a couple things that I'm going to do away from this to just set you guys on the right path, and a lot of these I have sourced from other videos, so I'm going to be leaving those links down in the description. There's one channel, I think it's the 3D Printing Dungeon or something like that. I can't remember the exact name, but he talks a lot about this, and he does an Ender 3 unboxing that really helped me out in understanding how to assemble everything on this particular printer. So I'm going to be following his guide, and just as a kind of reiteration of how important the topics are in that video that he talks about, I'm going to do them all myself and explain why I am doing them. So yeah. First things first, we should tighten up the bed, or the undercarriage for the bed, to make sure that's taut. So let me grab that part. Okay, so that was a lot. As you just saw me, I turned over the assembly and I checked the rollers underneath here. So on the bottom of most every 3D printer bed, sorry, dust. Weird noises. Okay. So on the bottom of most every 3D printer bed out there, there will be 4 or 6 bearings. And bearings basically are tight against this railing, and they allow the bed to move smoothly across this extrusion with the help of this belt. Now, if those bearings aren't making good contact, or they're not tight, what will happen is you'll get wobble in your bed. And what's really cool is Creality actually pre-tightened them, so I don't have to do anything. So, but normally if your bed has any kind of wobble, like that's a little bit normal, like that's stiff. But if it were wobbling significantly, what you would want to do is turn it over, tighten up those nuts, and you want to basically roll them to make sure that there's still free movement. If the bearing is just spinning but the bed isn't moving, or if it's so tight that the bed isn't moving at all, that's too tight. But there should be a little bit of grip, and when you spin the wheel, it should move the bed along this rail. So good on you, Creality. Thank you for pre-tightening everything there. Alrighty friends, so as you can see, we are up and running. I am running my first test print. It's just a basic calibration cube, and so it's going to take about 30 or so minutes to finish that, so not too bad. That's running at 50 millimeters per second for the print speed. I think I can push it a little bit harder, but for right now I'm just trying to get a base level thing. So all in all, the assembly I give like a 3 out of 5 as far as difficulty goes. There were some parts that you kind of had to assemble yourself that would come pre-assembled on some other 3D printers, but I think as long as you have somebody that is competent in 3D printing or has done it before, maybe you have a local makerspace you can go and they can give you some advice on how to assemble this guy. And it's a really great way to understand or to learn how a 3D printer actually works, because you have to put down the stepper motors or screw in one of the stepper motors, and you have to install the lead screw and all that good stuff. So it gives you kind of an idea of the kinematics that go into a 3D printer. And yeah, the bed leveling was super easy. They've got these big nice knobs and the bearings are really smooth, so it's really easy to tighten or loosen the bed. Now there is one downside in the vanilla firmware, I should say. I don't know what I was trying to say. In the vanilla firmware on this guy, there is no custom command section for like moving to the front left, front right, back left, back right. I'm sure you could just write those in Marlin or write your own G-code for it and upload it to that. So that might be something I have to do, but when I was doing the bed leveling, I had to move the axes manually through that guy, and it was not fun. And also, this does have support for USB, but it is mini USB, and I don't have a mini USB cable, so right now I'm running on SneakerNet. If you don't know what SneakerNet is, it's basically where you network two machines by using your sneakers or walking to it and moving stuff back and forth manually versus over a cord or a network. So I'm having to work with that, but I'll probably just pick up a mini USB cable. They're dirt cheap. And yeah, all in all, I'm very happy. First impressions are very good. And be sure to check out, we're going to be live streaming this printer, so whenever we're printing stuff, we're probably going to live stream it, and I'm going to be doing some upgrades. I can already think of a couple things that I want to do to this printer, one of which is a enclosure that's built out of IKEA furniture, so stay tuned for that. I'll leave you with that little teaser. And as always, if you liked the video, be sure to leave a thumbs up. If you didn't like the video, leave a thumbs down, and leave a comment down below if you're interested in continuing the discussion. And if you're interested, definitely subscribe to our channel so you can see when we make new videos. And we'll finish up this video in the normal way, and that is by me saying, always remember, friends, that you are wanted, you are loved, and you are appreciated. So you have a special talent that nobody else has, and the world is waiting on you to bring it out. So muster a little courage, go out into the world, and change it. That's what the world's waiting on. You.